Chemistry Chapter 11.4 Finding Molecular Formulas. Let's take a look at empirical and molecular formulas. A molecular formula is an expression where the number and type of atoms are present in a single molecule. It represents the actual formula of a molecule. An empirical formula is a simplified version showing only the ratio of the elements. Let's take a look at some examples. In the molecular formula, glucose is represented as C6H12O6. In the empirical, it is written as CH2O. Hydrogen peroxide is written as H2O2 and then is written as HO in the empirical. Although sometimes the two formulas can be the same, one example being H2O for water. Now let's try an example. Practice problem number 53 on page 335. A colorless liquid composed of 46.68% nitrogen and 53.32% oxygen has a molar mass of 60.01 grams per mole. We first need to calculate the amount of moles in each element, and we also need to assume that the sample is 100 grams. We already know the percent by mass for each of the elements in the molar mass. We first need to solve for the empirical formula, followed by the molecular formula. We first need to take the percent by mass as grams and divide that by the atomic mass of each element in order to get the amount of moles in each of the elements. We then need to calculate the simplest ratio by dividing the smallest value in the mole ratio. In this particular case, we get 1 mole for each element and a ratio of 1 mole to 1 mole. The empirical formula is NO. Next, we calculate the empirical formula mass using the molar mass of each element. We then get 30.01 grams per mole NO after adding. Then we divide the observed molar mass by the mass of the empirical formula to determine the value of N. We get a value of 2. Then we multiply the subscripts in the empirical formula by 2 to determine the actual subscripts in the molecular formula. The answer is N2O2 for the colorless liquid compound. Let's try another example. Practice problem number 51, page 335. Analysis of a chemical compound used in photographic developing fluid indicates a chemical composition of 65.45% carbon, 5.45% hydrogen, and 29.09% oxygen. The molar mass is found to be 110 grams per mole. We first need to calculate the moles of each element, and again, we need to assume that the sample is 100 grams. Again, we know the percent by mass for each of the elements in the molar mass. We need to find the empirical formula first, then the molecular formula. We first take the percent by mass as grams of the elements and divide by the atomic mass to get the moles for each element. Then we calculate the simplest ratio by dividing the smallest value in the mole ratio. We get 3 moles for carbon, 3 moles for hydrogen, and 1 mole for oxygen, giving us an empirical formula as C3H3O. Next, we calculate the empirical formula mass using the molar mass of each element. When added together, we get a grand total of 55.06 grams per mole C3H3O. Next, we divide the observed molar mass by the mass of the empirical formula to determine the value of N. We get an answer of 2. We then multiply the subscripts in the empirical formula by 2 to determine the actual subscripts in the molecular formula. Our final answer is the molecular formula of C6H6O2 in the colorless liquid compound. Thank you for watching my presentation.